This is a demo for the real-time data anonymization talk given in KubeCon 2021. So I'm going to show here how faces and license plate are being automatically blurred for images being uploaded to the Ceph storage system. Ceph is going to be configured and deployed using the rook operator. The serverless function that's going to actually do the blurring is going to be based on the Cada serverless framework, and the notifications from Ceph to this serverless framework is going to go over a RabbitMQ message bus also being deployed by the RabbitMQ operator. So we start from a clean microshift node. Except microshift, there's nothing else running there. You can see here the pods. And all the code for the demo is in GitHub, so you can get it from there. So the first thing I'm going to do, I'm just going to clone the repo. And then start configuring the system. So the first thing I would need is to get a storage provisioner for microshift. So this is the file doing this, and I'm just going to run that. After I have that, I want to install Rook. So the rook operator has a couple of components. The base rook operator has CRDs, the common, and the operator itself. You can see here that we're taking our developer build YAMLs because we have this is still work in progress. It's not really in mainline rook. This is why we need our special images. After we're gonna install the basic rook stuff, then we're gonna bring up the Ceph cluster. And after we have the Ceph cluster, which is the OSDs and all the backend for storage, we're gonna have our Redis gateway, our object front end being installed. We also need a toolbox to do a couple of operations. So let's run that. You can see that quite a bit of CRDs here being configured. And let's see what's going on. So you can see the rook Ceph. This is the namespace where all the rook stuff is being done. The basic stuff is already there, and you can see that the operator is there. Now we can also see the monitors, and the OSD is going to run there quite quickly. And after we have the OSDs and everything, we should have the Redis gateway. And the Redis gateway is the object store front end, and this is what's going to send us the notifications that we need for the whole thing to work. Yeah. So now we have the Redis gateway running, and I think we can start. The thing failing here are the CephFS and RBD. Those are other front ends for Ceph, for block storage and for file storage, but we're currently focused on the object storage here. Okay, so we have Rook up and running. We have the OSDs, the Redis gateway, everything working there. Now we need to create a bucket. So let's see how we do that. So we create a bucket. The bucket needs first a storage class, and after we have the storage class, we have the object bucket claim. It's pretty straightforward. It points to the storage class. It tells which storage class we're using. The storage class points to the object store we're talking about. In theory, there could be a couple of object stores in one cluster. And the special thing here is that we have this special label. So the label that starts with the term bucket notification, and then a dash, and then the notification name, and then there's the notification name. When we add those labels to an object bucket claim, then when we create the bucket, we would also go and look for a definition of a notification called my notification, and if we find one, then we also configure the bucket notifications associated with it. So let's create the bucket. Now the bucket will be created There'll be no notification because we didn't create it yet. But once there will be a notification, then we would know that this bucket needs to be associated with it. There's another step that we need to do here. This is one of the reasons that why we need our developer builds and we cannot use like the mainline builds. We're going to send a special parameter that would allow us to send the RabbitMQ user and password over clear text. In theory, this is not a good idea, but just for the sake of the demo, we're going to allow that because this would allow us to interact with the Redis gateway over HTTP and not HTTPS, but still send the user and password for RabbitMQ inside the message. Now we also need to set up the environment parameters. So the environment parameters are the name of the Redis gateway service and the access and secret keys needed for it. So let's source this file. So the next step, once we have Rook and we have Ceph and we have Redis gateway, we also need the RabbitMQ. So RabbitMQ is being installed also via an operator provided by RabbitMQ, and we're just going to run this operator. So the operator creates, we're going to first fetch the operator and then we're going to create a hello world RabbitMQ instance. Now you can see that on top of the default microchip stuff and on top of the all the Rook stuff, we also have a RabbitMQ operator, and we also have a RabbitMQ instance that we created in the default namespace. So now that RabbitMQ is running, we need to configure a couple things in RabbitMQ. So what we're configuring here is like, first we're doing the cleanup, and then we declare the exchange. Both the Redis gateway and the Cada consumer needs to know the exchange. The Cada consumer also needs to know the queue that it's being pulling the notifications from. And the queue is then, we do the binding between the queue and the routing key, and the routing key name demo has to match the name of the topic that we're configuring on the Redis gateway. So let's run that. And now we're going to configure the notifications. So let's see how we do that. First thing is we need to fetch from the RabbitMQ the name of the user and the password. Once we have them, then the first step is to create the CRD for the Ceph bucket topic. The Ceph bucket topic is the indication of where to send the notifications to. So we define an endpoint. The type of the endpoint is MQP. The user and password are taken from here, and as well as the name of the service. We also need to tell the Rook operator on which object store to configure this topic. So we give the object store name and namespace. And then we have some MQP specific parameters, like the ACK level, which means when do we consider notification to be ACKed. In this case, it's enough for us that the broker received it. And what is the name of the exchange we're sending the notification to. The routing key that we're going to use there is going to be the name of the topic, demo in this case. The last step that we're taking is to define the notification. Notification it is what ties together the topic, which is where to send the information to, together with the bucket. Now, the bucket definition doesn't exist here, but the bucket definition, or what ties the notification to the bucket, is in the label that we described before in the object bucket claim. So when we're going to create a notification, we're going to search for all the object bucket claims that has a label that matches the notification name and define this notification on these buckets. So the spec notification tells us what is the topic, where to send the information to, and when to send the information. So what kind of events. In our case, we're interested in object creation events. We just want to run our Cada serverless function when an object is being created, when an image is being uploaded. So this is why we're only interested in object creation events. So let's run that. And let's see what's actually being created. So when we look at the notification, we see the notification being created exactly as we defined it. When we look at the topic, we can also see the topic with the same spec. We see that the endpoint is configured with the username and password that we fetched from the RabbitMQ instance. And we can also see that the Redis gateway has allocated this topic with an ARN, which means that the topic was successfully provisioned on the RGW. Okay, so we have all that running, and now we want to install Cada, because just having the notification sent to RabbitMQ won't do anything interesting. Cada requires Helm to be installed. This is already pre-installed in this machine. So we're using help charts in order to install Cada. And now that we have Cada installed there, we need to tell Cada what is the actual serverless function that we want to be running. So the serverless function is being defined here. This is the YAML that tells us what is this serverless function. It needs to know which queue it's going to pull the data from, and this is the RabbitMQ consumer. And it has to know what it's going to do with this. And what it's going to do with this is execute the blurring functionality. So let's deploy that. Now the last thing that we need to do is we need to create the secrets that are needed, because for example this blurring function needs to go and fetch information from the Redis gateway. When it gets the notification, it needs to fetch the image, blur it, and then write it back. So in order to fetch that and write that back, it needs to know all the credentials. Now the credentials, we sourced them here from the outside of the cluster, so we can interact from the outside, but this has to be accessible to things running inside the cluster, for example the serverless function, so we have to add that as a secrets file. So this is the definition of the file. Sorry. Yeah, now it's going to create a file called secrets, and now we can deploy this file. Now the last thing that we need to do is to actually upload an image to the bucket. We can see here that we have the Cada operator running, and pretty much that's it, because the only other thing that we added here is Cada. Now we need to make sure that We source the environment script, so we have the credentials and all the information about the cluster when we are interacting with it from the outside. And now we can start uploading images. So let's see what's going on. So once the images are being uploaded, they're going to be bucket notifications sent to the RabbitMQ, and then Cada is going to spin the RabbitMQ consumer. So now we see the RabbitMQ consumer is running, so that's going to do the blurring. So now we can look at the log of this consumer and see what he does. So it takes a while, but you can see now that it's doing the blurring of the face, the license plate, and it's uploading the new image after being the blurring to the same bucket, overriding the name of the old image. Now if you want to see what the application actually does, so here's an example of one of the images that we're uploading. This is me next to my car. And this is the image after being blurred and being written back to Ceph, where my face and my license plate are erased. I hope you enjoyed the presentation, and if you have any comments or questions, please don't hesitate to contact Huamin or myself. We'll be happy to answer any questions, and we'll be happy to hear any feedback. Thank you.